Hello all, my name is Mahesh and welcome to this video. So in this session we are going to see an really interesting machine learning project, and the project name is Wafer Fault Detection. So the main problem statement here is we need to detect the faulty wafer devices. Okay, so before getting inside the topic, let me just give an quick introduction to the wafer device. So if you just see, so this is an image of a wafer device. So this circular kind of disc, and this wafer device is having some kind of sensors, like you can see the square kind of thing. So these are the sensors, and each and every wafer will be having like hundreds of sensors, and these sensors are generating some data. So based upon this data only, we are trying to classify or predict whether the device or the wafer device is faulty one or not. Okay, and these wafer devices are used in various industries. For example, in solar industries, means in order to manufacture the solar device, we'll be using this wafer device. Fine. So as I told, the problem statement is in order to build a classification algorithm which is need to predict based upon the quality of the wafer whether it is a good wafer or bad wafer. So this is a project architecture. Fine. So if you just see, we'll be having several steps in order to train the model. Fine. So the very first important thing is we'll be getting the data from the client. So that is nothing but in the form of batches for the training purpose. First time. Okay. And when it comes to this batches data, right? So the batch data is nothing but we'll be receiving a bulk amount of data by end of the day in a form of like CSV files, in the form of database, or which might be stored in the AWS S3 bucket in the cloud storage. So depends upon the client, they'll be providing. Okay. So once we receive the data, that is data ingestion. Okay. We need to validate. So next step is data validation part. So in the data validation part, we need to validate whether the given file is having some proper naming convention. So what is the meaning of it? So definitely our client will be sending huge amount of files for us in the batches. So we cannot just process, we cannot just ingest that files directly. Why? Because we have to verify whether the file is having a proper naming convention, and as well as whether the file is having proper number of columns. So that is nothing but in data validation part we'll be doing. So here we'll be using some regex patterns in order to validate the file names. Fine. So next what we do, we just do the data transformation. So when it comes to this data transformation, suppose just imagine our client is sending some CSV file. In that CSV file, we'll be having some blank cells. So that blank cells is very bad. Why? Because just imagine I want to insert the data into a database. Our database is not accepting that blank cells. So we'll be getting an error. So in order to avoid that, we'll be doing the data transformation part. So here, if in case if you're seeing any blank cells, will be converted into null values, and that will be inserted to a database table. Fine. We can see. So we are inserting that transform data into a database, and then that data which has been inserted to the database will be exported as a CSV file, and this CSV file will be acting as an input for the training purpose. So if you just see this part, okay, this part is nothing but data ingestion part. Okay, so this part is nothing but the data ingestion part. And here, so the next step is data pre-processing. So when it comes to data pre-processing, what kind of things we'll be doing? We'll be just removing the unnamed columns from a table CSV file, and we'll be separating the independent variables, that is x and y, for the model, and as well as suppose if in case if you're having any null values, missing values, we'll be imputing the missing values with the help of different kind of techniques which is suitable for that algorithm. And so next what we do, we just pass this pre-processed data, and we'll be converting this pre-processed data into a clusters. So what kind of clusters we'll be doing? We'll be using some k-means clustering algorithm in order to cluster the entire data into a separate clusters. And then what we do, we'll just train a specific machine learning model with respect to the particular cluster. Fine. Suppose I might be having like 3 different clusters. I'll be training random forest for one, XGBoost for one, and so on. Fine. So after training the models on these specific clusters, we'll be choosing the best model. Fine. And once we choose the best model, what happens? We'll just hyper tune. We'll just give some hyper parameters and train the best model further. Okay. So once we just tune the model and get the high accuracy, we just save the model in the environment. And then this model will be converted into, or will be creating some API in the form of API, or we'll be doing some different techniques. I'll just explain in the after some time, and it is pushed to the cloud. So this complete thing is nothing but training part. So this is the data ingestion part, this is the data pre-processing part, these 3 things, as well as this is nothing but the training part. Okay, this is a pre-processing part. Fine. So next, once we just we are having a best model, we'll be deploying that model in the production environment, in the application, integrating with the application. Then so once it is deployed in the production, so we'll be getting some prediction data, that is the sensors will be generating some data, and this data will be given from the client to us for the purpose of prediction. Then here also we'll be following the same steps what all things have been performed here. Like the very first thing is we'll be doing the data validation part and data transformation part, and that transform data will be inserted into a database table. Then it will be exported as a CSV file, and this CSV file is acting like an input for the prediction. And again we'll be doing the data pre-processing part for this as well, and as well we'll be doing the clustering on this as well. When it comes to this clustering, we'll be creating a clusters similarly here, and each and every cluster will be having a specific model. We'll be finding that model with respect to the cluster, and we'll be doing the prediction. And then yeah, that is what this, we'll be choosing the specific model for the cluster, and we do the prediction, and then the prediction will be converted into a CSV file and will be sent back again to the client. So this is a complete architecture of a project. So now let us just see the code implementation of the product. I hope you're able to see my pie chart, and this is a folder structure of our project. And you might think something like this. So in order to just develop an classification algorithm, why do we require like so much of complex architecture and so much of files as well as the folders? So in real time what happens, whenever you're trying to implement or you're trying to develop any kind of project, so you'll be developing in a modular way. So what is the use of this? Suppose just imagine you'll be working in a team. So in that case you'll be given a task. If you're developing your entire machine learning algorithm in a specific one file, so what happens if you want to add any new functionality, if you want to or remove some functionality, if you want to change something, no, so sometimes it'll be very difficult. Why? Because you need to keep on changing the logic Okay, but if in case if you are having some uh, some subtask, right? So what happens, example here, we'll be creating modules or we'll be creating separate files for logging, fine tuning the model, data ingestion part, data pre-processing part, data transformation part, and lot of things. Fine. And you can just see here this is a file structure. So we'll be having the requirement.txt. uh, so in this requirement.txt, I'll be having all the requirements for this project. And a very important thing, when it comes to this specific project, right? So it is I can just tell it is supported by Python version 3.6 or 3.7. Fine. And since we are implementing a project and we'll be giving the product to the client in the form of API, so web API, we'll be implementing or we'll be using Flask as an endpoint. So I'll just show you the logic. So this is a logic, the main.py. So main.py is nothing but the entry point of our application. Okay, so in this main.py, I might be having so in the main.py, so I'll be having like something predict URL as well as train URL. So and since we are using the Flask, right, the port number is we'll be giving like 5000, and we'll be running our application in the local host or in a local system, and uh, the host will be local host as well as the port number will be 5000 for this application. And the predict is nothing but the URL which is triggering the prediction pipeline. So train is nothing but it is triggering the training pipeline. Okay, so let me just come back again here. If you just see here, so I'll be getting inside the main.py and inside the train. So that is train root client. So this is a function. So if you just see here, I'll be clicking on this function method. So the very first thing what is happening here is it is importing all the modules which is required, and very first thing, as I told initially, it will be extracting the values from the training schema. So where it is available, it is available here. So you can see here. So in this training schema, as I told initially, we'll be having a format for the file which will be given by the client. So this is the file format, an example sample file. Okay, so wafer followed by underscore followed by date stamp followed by underscore and timestamp. So this should be the format which has to be followed by the file which my client is sending. If in case if any file which is not meeting this format, what happens, it will be moving to the bad data folder. Okay, it will be moving to the bad data folder. So so you'll be created something called as suppose just a minute. So as of now I'm not having any files. So you can see I'll be having like a bad data folder. Within that bad data folder, what happens, the file names which is not meeting this format, it will be moved to this folder. Suppose if in case a file is meeting the format, what happens, it will be moved to the good data folder. Fine. So the next step, fine. So first step is nothing but validating the file names as well as the columns. Next thing, so I'll just come here back again. So as I told, we'll be using the regex in order to validate this. You can see. So this is the regular expression which is used to validate the file name. Next. So if in case the data is not meeting the requirement, it is meeting the requirement, what happens? We'll be creating a folder called as good raw, which will be moved, the good data will be moved to the good raw folder, as well as the bad data means which is not meeting the requirement will be moved to the bad raw folder. Fine. So next, what happens? We'll just move back again. You can see we'll be validating these things. First, we'll be checking the file name manually with respect to the regular expression. Then validating the file name, validating the column length name, and if in case if any missing values is available in the whole column, we'll be dropping that column. Okay. And if in case if any column is having some specific missing values, which will be replaced. Fine. So the same thing what I told initially. Suppose I might be having an empty cells. So empty cells will be replaced with null values. We can see here. Empty cells will be replaced by null values. You can see. Fine. Next. So once the validation part is finished, next what we do, we just create a table and insert the data to the database, means the validated data. So here we'll be using SQLite 3. So what I'll do, I'll be creating that table, then I'll be inserting the data to the table, that is we'll be inserting the good data, good training data to the table. Then again, once the data will be inserted to the table, right? So what happens? Let me just try to explain this thing. So assume that I'll be having the files, okay? I'll be having the files in the good raw folder. So these files will be moved to the database. These files will move to the database. So once it is moved, what happens? We'll be creating a table, it'll be moved. So after moving this, what happens? Again, we might be having duplicate data here as well as here. So in order to avoid the duplication, what we do, we'll just delete this from the good raw folders, and we'll be using this data for the training purpose. Fine. So what happens to the bad data files? So bad data files will be moved to the archived. Why? Because don't think that this bad data files is not used, and again I have to contact my client that saying we have been received some files which is not meeting the requirement, so please just look back to it and send again. Fine. So in order to do this process, what we do, we'll be moving this or the bad data files to a archive folder. Okay, you can see here these things. So this is the archive bad data folder which will be moved to this folder, and we'll be sending this all the bad data files to the client back again. Okay, so now let me just get inside this. So now what happens, means we're able to send the data from good data folder to the database, and this database means the data which is available in the database will be sent back to the CSV. Means, so what is happening here, we'll be extracting the data from the database, and that CSV file will be acting as a input data to the training phase. Okay, or maybe the next phase, that is pre-processing and so on. Fine. So you can see so the next phase is training phase. So when it comes to training phase, no, so training phase, what happens, first of all, very important thing will be getting the data. So that is nothing but we got the data from a database, that is a CSV file. Next, on top of that CSV file, what we do, we just do the data pre-processing. Fine. So here what we do, when it comes to pre-processing, we'll be removing the columns. For example, like we'll be removing the columns which is having so unnecessary names. Maybe it is not having some proper column name, we'll be removing that, like unnamed column. Fine, because it is not useful for the training purpose. Okay, And so once we just remove the unwanted columns, we just split the data into X and Y. And after splitting the data, what happens? Now we just apply the pre-processing part. Fine, like we'll be imputing the, we'll be checking whether there is any null values. If in case if it is available, if there is any null values, if it is available, what we do? We just impute the missing values. How? With the help of this KNN imputer. Okay, with the help of the KNN imputer, we'll be imputing the missing values. So next, what we do? We just after imputing the missing values, we'll be getting the columns which is having 0 standard deviation. So what do you mean by this? Suppose just imagine I might be having a column, I might be having a data frame. In the data frame, a specific column is having only zeros, or maybe any constant number. So in that case, so for this specific column, if I'm trying to calculate the standard deviation, definitely, or many mean, it will be 0. Fine. So these kind of columns will be identifying and removing it. Why? Because it is not influencing, or it is not useful for the training purpose. Why? Because since we are having the constant values, it is not contributing more to my model training. It is not contributing to learning for the model. Okay. And then, so once we just remove all the columns which is having standard deviation is equal to 0, then now what we do? We just apply the clustering approach. Means with the help of K means clustering, and with the help of this elbow method, we'll be finding a good amount of means the best number where we can just split our data into clusters. Fine. So what is the importance of this? I will explain. So okay, so just imagine that so this is our data. So I might be having like the data point something like this, so which is not arranged, or which is not distributed properly, and this kind of data will be seeing in the real time. Okay, so we might not be seeing a proper data, so this kind of data we might be seeing. So assume that this data as of now, assume. So if I'm just training and linear regression on top of this data set, so definitely I'll not be getting a best fit line. It might be skewed. Why? Because I might be having some variance in the data. So it is the best approach that I can divide this data into clusters. So we'll be having like huge amount of data, so that we can divide that data into clusters, some clusters like this. So if I'm trying to train, and specific means, as I told, we'll be creating the clusters. Assume I'll be giving the name C1, C2, C3. Fine. So here what I'll do, we'll be taking a specific cluster, and we'll be taking a specific machine learning algorithm and giving this C1. For example, what I'll be taking this C1 and I'll be giving to the random forest regressor. Okay, so random forest algorithm. So what happens? It will be able to try to fit a best fit line somewhere here, and as well as I'm giving something called as XGBoost for this. It is able to create a best fit line here, something like this, and so on. If you just see here, so for this specific cluster, this algorithm, or that machine learning algorithm which have been chosen, is performing best. So rather than creating something like which is not a proper best fit line, so instead of creating something like this, I can cluster my entire data into samples or clusters, and what I can do, I can just train a specific machine learning model on top of that specific cluster, so that I can just choose a best fit or best model. Suppose just one more scenario. Just imagine I might be getting a new prediction value which is somewhere here. So it is not required for me to use this the machine learning algorithm, the model which has been used to train this C1, since this data point is belonging to this cluster. So since, and again I'll be having a dedicated machine learning algorithm or model for this C3, I'll be using that algorithm or model to predict this value. Fine. So that is the use of this thing. Fine. So now let us just get inside the code. So here, so once the clustering is done, and as I told that we'll be training a specific machine learning algorithm for a specific cluster. Fine. So then what we do, we'll be finding the best model. Means you can just see I'm having the code for it. You can see, so this module tuner module is nothing but it is having a class called as a model finder. So in this class we'll be having multiple models for a specific cluster. Here random forest classifier as well as XGBoost classifier. Fine. So what we do, we just find the best model from all of the clusters, and on top of that best model, what we do, we just do the hyperparameter tuning. Fine. So next, let me just showcase the code. So when we are trying to train the models with respect to the specific cluster, so we'll be using grid search CV. Why? Because once we receive the different type of models for a specific cluster, we need to do some hyperparameter tuning in order to get the best model first. So like for random forest regressor, I'm giving these are the hyperparameters. So like I'll be giving like n estimators, number of estimators like 50, 100, sorry, 10, 130, and I'll be using Gini impurity as well as entropy, and the max depth I'm giving this range, and max features I'm giving auto as well as log 2. Fine. So I'll be using these hyperparameters in order to train the random forest classifier. So when it comes to this XGBoost, right, I'll be using this learning rate, different kind of learning rate as well as max depth and number of estimators. So by using this hyperparameters, I'll be training my XGBoost model. Fine. So once we're done with these things, we'll be just selecting the best model out of these two things. How we'll be selecting the best model? We'll be selecting the best model based on accuracy score as well as ROC AUC score. Since it is a classification algorithm, we have to just find the best model with the help of accuracy as well as ROC AUC score, and we have like a different kind of metrics as well. The best thing is we can use ROC AUC score. Fine. So then once we just select the best model, we'll be saving that model in a folder. Fine. So where we'll be saving the model? We'll be saving the model somewhere here. You can see. So here what is happening? XGBoost is performing well over the random forest classifier. So that is the reason it has been selected the XGBoost and saved. You can see. So 0 for the cluster 1 first cluster, XGBoost 1 for the second cluster, XGBoost 2 for the third cluster. So we are having 3 clusters here. Fine. So once we find the best model, what we do, we just save the model. So we'll be saving it as a pickle file, or you can just save in different kind of format like joblib, sav, and pickle. So you're having a lot of options. Fine. So now what we do, so once the training is done, so now our model is ready for the prediction. So then we'll just move to the prediction pipeline. See, so since I told that, right, when it comes to prediction also, the same process will be followed. Maybe like we'll be extracting values from the prediction schema, and then it is entering inside the raw validation. Fine. So we'll be extracting values from the prediction schema. Prediction schema. So once we just extract this values from the prediction schema, what we do, we'll be validating whether the column name or uh, file name which is meeting the format. So with the help of regex pattern, we can achieve these things. So next thing, so we'll be doing the data transformation part. So data transformation part, okay. So in this data transformation part, what we do, we just impute the blank values with the null values. So in order to insert the data to the database, so blank to the null values, that is nothing but np dot nan. Fine. So once we're done with this, what happens, we'll do the data type validation. So in this data type validation, what we do, we'll be creating the database, and we'll be uh, inserting the data to the database. Okay. So here what happens, we'll be validating the data, right? If in case if my file is failing here, what happens, again same old thing, we'll be moving to the good raw data folder and bad raw data folder. Okay, we will be moving the data to the good raw data folder as well as bad raw data folder. Fine. So the next thing, what happens, so next thing, okay, I'll write good raw as well as so bad raw data folder. Fine. So this good raw data folder will be inserted in database, into database. Fine. Again this database, from this database what happens, we'll be getting the CSV file. So it is acting as an input for what, prediction. Fine. So it is acting as input for prediction. So then what we do, we'll just take this CSV file, then it will be given the input for the model. Okay. So when it comes to the model training part, the very first thing is data pre-processing. Data pre-processing part. And so in the data pre-processing part, what all things we'll do, we just remove the unnamed columns, and it is not required for the prediction, and we'll be creating like we'll be splitting our data into x and y, that is dependent as well as independent. So that is like we'll be creating like x and y, and removing the unnecessary columns and imputing the missing values. Fine. And then what we do, we'll just try to find a column which is having standard deviation is equal to 0. Fine. And we'll be removing that thing. We'll be removing this columns which is having standard deviation is equal to 0. Fine. So then what we do next, we'll be once we just drop these columns, fine, we'll be creating the clusters. The clustering part. So once the clustering is applied, what happens, we'll be getting the clusters of data. So again here, so if you just imagine, so if you just remember previously, when we are trying to do the training part, no, we got just 1, 2, 3 clusters. Fine. So we'll be using the similar approach only. Fine. So with the help of the same clustering algorithm, so model, what we do, we'll try to predict, we'll try to predict cluster for this our input CSV. Fine, the prediction data, and we'll be creating the column for this in column, new column, something called as cluster number, and based upon this cluster number we'll be dividing the data, and with respect to the cluster 0, I'll be taking XGBoost 0 model in order to do the prediction. Okay, 0, 1, 2. So I'll be grouping my prediction data into 0, 1, 2, and this cluster 0 will be given to the XGBoost 0, and so on. Similarly, XGBoost 1, XGBoost 2, and that particular model is predicting the values. Okay, so that will be more efficient. Fine. So then next, so once we just do the prediction part, no, so what happens, we will be just getting an output as a CSV file, that is prediction.csv prediction.csv. So this prediction.csv file is saved, will be saved. Okay, so you can see it will be saved somewhere here, prediction output prediction.csv. So here what happens, we'll be able to predict all the faulty wafers. So this is a wafer number, this is the index -1, you can see. So these are the faulty wafers, and I might be having so good wafers as well. So you can see. Fine. So here I'm getting only the faulty wafers. Fine. So the next part is this. So I'll just show you a quick demonstration of this thing. Okay, so in order to execute, in order to run this project, so what you can do, we can just open your terminal. So make sure that you're installing all the requirements in this for this project, and so it's best to create a separate environment for this. So have been created the environment. What I'll do, I'll activate the environment. So you can see. So what we need to do, we need to just execute just one command, that is nothing but python space main.py, enter. So what happens, it will be initializing the Flask server, and if you just see, since we have been given, so what we have been given, the host is equal to 0.0.0, so it's a port for the local host. And so what is the port number? 5000. Fine. So we'll be initializing the server. You can see our server has been started. So the port number is this. So what I'll do, I'll try to showcase you these things. So localhost 500, sorry 5000. So this is my endpoint, this is my front end part. So you can see I can enter the absolute file path for the prediction. So or I can just give the default file for prediction. So my results will be displayed here, and you can see few people are examining the wafers manually, you can see. Fine. So what I'll do, so I'll do one thing, let me just minimize this thing. Fine, so that it will be visible for me, and I wanted to show you few logs as well. So before getting inside this, no, so what I'll do, I'll be showing you few logs here. So if you just see, I'm having like prediction logs. Okay, so see, so when it comes to this prediction, let me just remove all the all tabs. See, very first thing what happens now, column length validation started, means I'll be initializing the column length validation and it has been completed. So the next thing, so data transformation part. So what happened, so these are the files which has been transformed successfully. So once the data transformation is finished, so what happens, we'll be creating the uh, good data directory, means good raw directory and bad raw directory. Okay, so this is next phase. Yeah, so the file name validation, you can see uh, the valid file name means this file is valid. So what is happening, file move to the good raw folder and this is a file name, and file move to the bad raw folder and this is a file name. So you can see it is not meeting the requirement of the, means it is not meeting the format of the file. So that is the reason it is moved to the bad raw folder. So similarly you can see so many files are there. I'm having huge amount of files. Okay, so next since it is moved to the bad raw folder and good raw folder, so the next thing is db insertion. You can see so the database table is created successfully. Next thing is db insertion log. So here what is happening, so what are all files we are having, right, which is available in the good raw folder, which will be loaded successfully in the database. All these files are inserted in the database. So where is the database? As I told, since we are using the my means SQLite, will be getting something like this. Okay, so you can store the data in AWS. You can store database in any kind of database. So data in any kind of database. So as of now I'm just using SQLite for the simplicity. Fine. So next what I'll do, yeah, so what is the next log? Here I'm just exporting to CSV. File exported successfully. So the next thing is prediction log. You can see the first thing. So what is happening here? Starting the validation of the files for prediction, raw data validation completed, starting data transformation. So once the data is transformed, once it is starting the data transformation, you can see these are the steps. Creating a prediction database and tables on basis of given schema. Table creation completed. Insertion of data into table started. Insertion of table created. And again, so once the data is inserted into database, so we'll be deleting the good raw data or good data folder. Fine. And again, we'll be moving the bad data folder to the archive. Fine. Next, so once we just done with this, so what we do, we just so do the validation part, extracting CSV from the table, then starting the validation part. Okay, I think so once it is done, so what happens, the outcome is the CSV file for the prediction. Fine. Next, so next what I'll do, so let me just remove all these things in front of you. So I'll try to predict in front of you, so now itself, so that you can see the logs. So I'll try to make it more interactive. Fine. Fine. So these things are more than sufficient, I think. Fine. So what I'll do, so let me just go back here and click what? Click like default file prediction. So what is happening? It is starting to predict. Fine. So let me just see the log in real time. You can see the log has been initiated, means the name validation log has been initialized. You can see it is logging. Fine. So the next thing, so it might take some time to log. You can see it is moved to the good as well as raw data folder. Fine. We can see database connectivity has been done. So I'll just show you this thing. Yeah, we can see good raw data folder as well as bad raw data folder. Fine. So what happens now? After some time, since I'll be moving this bad raw data folder to the archive as well as good raw data folder to the database, it will be removed automatically. So it will be taking some time because we'll be having like huge amount of files, so we have to just maintain. You can see data transformation has been done. Yeah. So if you just see now, right? So in my uh, these things, training raw files validated. No, I'm not having any kind of good raw data as well as bad raw data. So where it is available, it has been moved to the where it has been moved to the archive bad data. Fine. So we can see these things. So good raw data directory deleted successfully, and bad files moved to the archive. Bad raw data folder deleted successfully. Fine. So next these things. So here again these things. I hope you're able to see insertion log of database. So again, once it is done, right, I'll be getting an prediction in the form of JSON format. So you can see here are some predictions. So wafer number, what is the prediction? Wafer number, I'm getting a -1. So these are some predictions. And we just came to the end of the session. So as you have seen, we have been implemented some really interesting machine learning project, and I hope you're able to understand. So all of the things have been explained, and thank you for having so much of patience in order to listen this entire project. And so thank you guys, and see you in the next video.